Good afternoon, everyone. I'm Fumiya Shigemitsu from ISO, a real-time operating system vendor in Japan. Today, I'm going to share some thoughts and experience from playing with Clang Static Analyzer. Let me start by explaining why I'm interested in Clang Static Analyzer and focus on WH issue. There are many commercial tools for static analysis, and they work well for many use cases. However, there are times when we want to custom checks that we really need for more freely to suit our project. Clang LLVM is open source, hackable, and already part of our tool chain. That's why I decided to build a custom checker on top of it. As a real-time operating system developer, we face specific challenges, especially in OS level security. One example is double fetch. It's a great case to study for static analysis and also relevant for our work. Look at the right side of the slide. Before explaining my checker, I will briefly explain how double fetch bug works. The kernel reads the user memory firstly, then does something, and later reads the same memory again. If a user task or attacker changes that value during the gap between first read and second read, the second read no longer matches the first read. The area validation is now useless and can lead to vulnerabilities such as buffer overflows, which may result in privilege escalation or even cause the system to crash. Okay, now I will give you a quick overview of how my checker works. First, memory access provenance. Every load from user space is recorded with a unique provenance tags. Then, alias relationship. The checker tracks those tags across all symbol aliases. This ensures that any alias of data keeps its original provenance tag. Then, control flow analysis. Whenever a branch condition uses a tagged data, the branch condition itself becomes tagged, keeping all downstream uses in sync. Finally, double fetch detection. When data is used with mismatched provenance tags, the checker reports double fetch. Okay, let me show you a simple demo. It's actually a picture, and sorry, right side of terminal does not show the actual reports. This is my bad. So let me briefly explain the left side of the code. This is a slightly artificial but useful for illustrating double fetch issue. Firstly, kernel reads a user pointer into length 1 and then use it to allocate memory. Then, secondly, kernel reads a user pointer again and use it to check the size before copying actual data. If the contents of user pointer changes between two reads, for example, by another thread, the copy size and check size may not match. This will be detected by my checker. Okay, then next, as you might expect, reducing false positives is critical for practical use. Let me show you what kind of false positives I try to address. First, pointer changing. Even if the same name is used, same variable name is used, the pointer may change between two reads. It is not actually a double fetch. Thanks to LLVM APIs, the checker easily solve this issue. Second, use of double fetch data. The checker sees how the data is really used. So just detecting two reads isn't enough. The checker only flags paths where the double fetch data is really used, and at the place branches or writes. These are mentioned in the survey paper in the static analysis for double fetch issue. Okay, finally, here are some ideas for future work. And from this work, I found that Clang Static Analyzer makes it easy to build custom checks. So I hope to use it more and suggest improvements if possible. Thank you for listening.